If our purpose is to analyze the data and ensure compliance with good clinical practice, we need to begin by figuring out what data is key to the analysis and what data will give us insight into GCP. We do this by looking at the protocol and the analysis plan, and we can use those to identify the primary and secondary outcome measures. Then we look at additional data that can provide insight into good clinical practice compliance. For our MOC-001 study, we can look at the primary and secondary outcome measures in the protocol, which are pregnancy and bleeding or spotting. Next, we add the data that provides additional insight into safety and efficacy, as well as GCP compliance. This is going to include your common identifiers. You have to know who the patient is. That deals with randomization. Informed consent. They have to have consented. Were they following inclusion-exclusion criteria? Did they comply with the dosing schedule? Were there adverse events? Were there concomitant medications or other deviations that could impact the data or the compliance with GCP? Once we've identified the key variables and how we want to check them, we document all of this in a quality control plan. I've created a very simple quality control plan for CLR MOC-001. Hopefully you already know what I'm about to say. You can find this document in the Data Management Study file. I've also posted a link to this document in the Module 7 content folder. I want to emphasize that the document name and the version number are present in here. So remember, you always have to make sure that you've identified version. You've got to have that version control. I want you to review this entire document, and I will put questions from the document in on your midterm. After you've completed your quality control checks according to your quality control plan, you need to document the results. Typically this is done in a quality control report or audit report. I've created a very simple quality control report template for CLR MOC-001. You can find this template document in the Data Management Study file, and I've also posted a link to the file in the Module 7 content folder. You're going to need to use this template to do your assignment. I want you to record your findings from the Module 7 assignment in the template. Remember, you might need to modify the table to make it work, so don't just assume that you can add rows, you can add columns, you can do what you need to do. Once you have recorded your findings, you're going to need to submit that report to me using that report document using the Module 7 assignment submission link. Ask me if you don't know how. PROSCA says a locked database defines the point at which final analysis can start and conclusions can be drawn on the data. And that's well and good, but what do we mean when we say we have locked the database? Well, in most cases, that simply means we've altered the settings on either individual user accounts or the data sets themselves to ensure that records can no longer be changed in any way. They can't be modified, they can't be deleted, you can't add to them. Why would we want to do this? Why would we want to remove access to these records and stop changes? Well, we do it because we want to preserve a snapshot of the data that was used to create an analysis. So, for example, if you ran your analysis on 50 patients worth of data and you knew that at that point in time they had 70 adverse events, if somebody wanted to look a little deeper into the adverse event profile and wanted to run new programs to review it, you would want them to use exactly the same data that was used to produce the first analysis. So we actually are going to lock down the database, and we create data sets typically and transfer them out into another directory where we lock access to those two. There's a lot of locking, a lot of access restriction. There are generally two types of locks, a hard and soft lock. A hard lock is intended to be final and permanent. You usually do this at the end of the study, and the intention is that you're going to freeze the database forever and ever at the point of analysis. And a soft lock, however, is intended to be temporary. You use a soft lock when you want to stop updates for a short period of time while you take a look at data that has been collected to that point, or perhaps data that meets certain criteria. For example, you might want to look at all patients that have gone through dosing regimen 5. So I wanted to point out you can also hear people use the term freeze instead of lock, so don't be surprised if you hear people talking about a soft freeze or a hard freeze. Some people distinguish between the two, but really I think they're used pretty interchangeably in the industry. So since you have a lot of steps you need to go through before you lock your database, you'll want to have a checklist, and typically that's going to be a study-specific document, and you're going to store it in your data management folder when you're done, or your data management study file. There are a lot of different tasks and steps that are going to occur, and many of them will be project specific. For example, if you do not have a central lab, you don't have to do the central lab to CRF database reconciliation. So you need to look at all the moving parts of a particular project and then create your project-specific lock list. And I have an example here that's just from, I think, one of the hospital-based sites, but you can see some of the things that they look at. This is for paper studies where they have to make certain that all the CRFs have been collected and that all the data clarification forms or queries are resolved. So those sorts of things. This type of plan is typically just titled a database lock checklist or checklist. And I encourage you, when you do your reading, to examine Proxka's 2 examples. She has them in Chapter 13, Study Database Lock, which is your assigned reading. They are figures 3.1 and figures, or 13.1 and 13.2. So enjoy that. That will be very helpful. When you do look through the MRF presentation, you're going to see he discusses why what the factors are that we look at in an interim decision. And I think you'll be surprised because, as I said before, it's not just safety. They also check recruitment rate and completion schedule. And the reason they do this is if the patients aren't being enrolled quick enough, you might say, we're never going to get to the sample size we need, and therefore, again, it's unethical to have the patients we have enrolled continue with the trial. You might look at the baseline characteristics and then assess the risk profile, kind of a safety issue. You could compare baseline and make sure that you actually have a patient population and an appropriate control. You could see how well people at the sites are complying with the investigational product as an intervention treatment. You might assess whether the data is complete and we've got appropriate follow-up for the patients. You might be looking at internal consistency. So what are the outcomes and what is the safety profile? And you also just might be looking at statistical issues. Do you think that you're getting your, again, sample size and power, and also ethical issues? So there's a lot of things that people might look at when they take that interim peek at the data. This is a nice slide that gives you an idea of when a DSMB is required. So the NIH, when you're doing studies for NIH, they're going to require a DSMB for protocols that generate blinded or randomized data, which is pretty much most of the studies we worked with. For multi-center protocols, those with more than one investigator site. And for gene transfer protocols, and this is really because in the early genetic studies, there were a number of very sad and instances where people died in phase 1 trials, so they're very careful about gene transfer. We don't know a lot about it. Studies that may require a DSMB are studies that pose less than minimal risk, and protocols that require special scrutiny, like those that are of high public interest. I'm trying to think, like an Ebola trial today might be one of those. And those that involve vulnerable populations, for example, individuals with advanced Alzheimer's who can't always advocate for themselves, so you want to get in there and make certain that they have extra safety protections. When you are dealing with the FDA, what they're really looking at, their criteria for whether or not you have a DSMB, is risk to trial participants. So that could be the study endpoint. Is it death? Is it, you're talking about an oncology trial. So also trials of long duration. They want you to take a look partway through that trial so they can see what's happening as opposed to waiting towards the end. Or fragile populations. These are patients that are very sick and vulnerable. Something could go wrong within the trial, and you want to protect those individuals. Practicality. Typically for DSMBs, you're not going to be seeing them in as many of the shorter trials. And they also are looking, they want DSMBs when they want assurance of scientific validity. So if they're going to be including scientific knowledge without adding a bias there, they want to have somebody that is unaffiliated with the trial come in and take a look to do the independent monitoring. So another very common reason to do a soft lock on the database and send a snapshot of the data out is to have somebody perform some independent monitoring. So, a lot of the review that is done on a trial is done by a CRO hired by a sponsor or by a sponsor, but there is a requirement for many trials that the safety and efficacy of the data is reviewed at interim points throughout the trial, key points, by a group that is totally independent, that has nothing to gain from the drug being approved or the trial continuing.
We've got
and so there's a variety of different independent monitoring groups,
your dog
and I just want to give you a few of the more common names. You might hear people talk about a data and safety monitoring plan. That's essentially a plan that says how you're going to monitor the progress of the trial. What are you going to check, and how are you going to ensure the safety of the patients? And what is the mechanism for reporting adverse events to the IRB and for ensuring data accuracy and protocol compliance? So that's sort of, the DSMP is typically utilized by a DSMB, a Data and Safety Monitoring Board. And again, this is a group of people that are qualified to look at the results of the trial and determine whether there are safety signals or, in some cases, efficacy signals that would require the trial to be stopped early or changed. You might also have a clinical endpoint or events committee. So, for example, if you're doing a trial on, let's say, this is a very simple one, probably not the best example, but if you're doing a trial and you want to ensure that patients genuinely had a heart attack, that they just didn't have symptoms that appeared to be myocardial-like, then you might have 2 or 3 independent reviewers review the laboratory results or the EKG results for patients that are entered in the trial, and those 3 independent reviewers would review that event and tell you whether or not it was actually a heart attack or something else. So again, you might hear people talk about a CEC. And finally, another term is Independent Data Monitoring Committee, and this is really a lot like a DSMB. The terminology is just a little different. And again, you're seeing, I hope, a theme here that the focus, all these words say safety or monitoring or event, and really you're looking at having an independent group that's taken a look at the data and saying, are these patients doing okay, and are we running this trial all right? So a lot of times we do a soft lock and pull data for those groups. Do we do or use DSMBs or independent monitoring committees for every trial? No. The NIH and the FDA actually have some hard requirements for when you need to have that independent monitoring. But and sometimes sponsors will decide they want it anyway, because if something goes wrong with the trial, it's nice if the sponsor can say, we weren't hiding anything. We had an independent group review this. So some sponsors do it even if they're not required to. But Murph will talk more about this. But in general, the first decision tree is it clinical research or not? If it's not clinical research, generally you don't need a DSMB. If it is, then you want to ask yourself, is it a phase 3 trial, which is typically larger and more involved, or a multi-center trial? If it's phase 3, you're usually going to want to have a IRB and a data safety monitoring plan and a data safety monitoring board. If it is a multi-center trial, then it's still up in the air. Maybe you need one, maybe you don't. So maybe you have a phase 2, but you have a lot of sites. So then you have to ask yourself, is the trial blinded? Is the intervention or product that you're using high risk as opposed to low risk? Or are you in a vulnerable population, let's say people with diminished capacity? If the answer to any of those are yes, then you're probably going to need an IRB and a data safety monitoring plan or a data safety monitoring board to go with that plan. If the answer to all those questions are no, and your study's not blinded, there's not a high risk in the intervention you're using, and your population is not vulnerable, then no, you don't need to have that data safety monitoring board. So I think you'll enjoy reading through the Murph presentation. It's good information. So why do we need SOPs? Why do we care if we have written standard operating procedures? Well, there are two reasons we care. The first is that it's a regulatory requirement. ICH E651.1 says the sponsor is responsible for implementing and maintaining quality assurance and quality control systems with written standard operating procedures. And 21 CFR Part 11 also requires written policies and procedures. So there is a regulatory requirement. But again, we always want to ask ourselves, why do we have a regulatory requirement? Well, we have a regulatory requirement because it makes good sense. When you write down standard operating procedures, you build consistency into your system. If your procedures are written down, everybody knows how to do them. They know exactly what's expected of them. And even if their tasks are separated by length or time, they can come back to the written procedure and figure out what they need to do.